There's a mysterious dent in our planet's magnetic field, and it's slowly growing. It stretches from South America to Africa, and what's horrifying is that it's weakening Earth's protection shield against the Sun. They call it the South Atlantic Anomaly. And while most people on Earth don't feel its effects for now, satellites and spacecraft passing through it already do. Deep inside our planet, there's a giant ball of molten iron and nickel, the outer core. The metal inside is so hot that it's constantly moving and swirling. This movement creates electrical currents, and when electricity flows, it generates a magnetic field. This field surrounds the entire planet like a protective bubble. Without it, life on Earth would be in serious trouble. The Sun blasts out charged particles called solar winds that could destroy our atmosphere over time. Luckily, the magnetic field deflects most of these particles, keeping us safe. Other planets without magnetic fields like Mars lost their magnetic fields, got their atmospheres stripped away, leaving them dry and lifeless. And also, without the magnetic field, our technology and equipment gets all messed up. Satellites, power grids, and even airplanes could get hit by intense radiation. This would lead to communication failures, GPS errors, and blackouts. And now, something strange has been going on underneath the African continent. An enormous blob of dense rock deep inside the Earth, called the African Large Low Shear Velocity Province, has been growing and messing the magnetic field up. Scientists think that this weird rock-like thing is messing with the flow of the outer core, disturbing the magnetic field above it. That disturbance is what weakens the shield over the South Atlantic. It's like a crack in a windshield. It might not shatter immediately, but the weak spot spreads over time. Now, NASA is watching it closely. Satellites passing through this anomaly experience random glitches and shutdowns. Sometimes their circuits short-circuit from high-energy solar particles. Mission operators have to turn off systems before entering the danger zone, and it's only getting worse. The anomaly is drifting westward. This means that new areas could fall under its influence. What's even worse, it seems like it's been splitting in two, which means our planet has been developing two weak spots instead of one. And here's something crazy. Some scientists believe that this entire thing is part of a long-term cycle that's been repeating for over 11 million years. And that cycle would make our magnetic poles flip. North could literally become south, and vice versa. Earth's magnetic poles have flipped before, although the last time that happened was 780,000 years ago, way before humans started roaming around the planet. These reversals happen every few 100,000 years. Now, some wonder if our anomaly is the beginning of the next flip, but scientists aren't sure if we're overdue or just in a temporary phase. Luckily, if a flip were to happen, it wouldn't be instant. It would take thousands of years. But as the field weakens, more radiation would reach Earth's surface. It would mess up not just technology and equipment, but also us, and even animal migration patterns. Many animal species use Earth's magnetic field to navigate. And they even have some potential culprits that could have caused this weird thing. There are two massive, mysterious blobs of hot, dense material deep inside our planet. One is under Africa, and the other formed under the Pacific Ocean. They're called large, low-velocity provinces. Basically, huge underground rock-like formations. Both blobs are gigantic. Each one is hundreds of times taller than Mount Everest and stretches across thousands of miles. They make up 6% of the entire Earth's volume and are one of the biggest geological features inside our planet. They're also super weird and could be structured more like trees than some lumpy mountains. Scientists imagined them as softened rock at first, but based on recent imaging techniques, it looks like they might actually have jagged, branch-like structures extending upward. These are like branches of a tree, They could be feeding hotspot volcanoes at the surface, like the ones in Hawaii. Scientists still don't know exactly what these blobs are. However, they believe they control a lot of what happens on Earth's surface. Stuff like volcanic eruptions, earthquakes, and, of course, changes in the magnetic field. They may also be linked to supervolcanoes and mass extinctions. The eruptions that they could cause could be like the ones that happened in ancient times and possibly wiped out entire species. If the blobs are connected to supervolcanoes, they might have had absolutely insane disasters in the past and might even cause more troubles in the future. But they also help us control plate tectonics, which affect earthquakes and mountain formation. They might also contain material from Earth's early days, or even from Theia. That was the mysterious planet that crashed into Earth and helped form the Moon about 4.5 billion years ago. Finally, Earth literally breathes because of these blobs, which is insane. The Sun and the Moon's gravitational pull stretches the Earth slightly, making it rise and fall like a breath. But now, scientists found that this tidal movement is slightly off-kilter over the blobs. They literally interfere with how the Earth's mantle moves. These two huge structures actually actively affect how our planet behaves, which is super dangerous. We only recently learned how these blobs actually appeared on our Earth. It's all because of the sunken ocean crust. Over hundreds of millions of years, parts of the ocean floor have sunk deep into the Earth's mantle. These slabs of rock stacked up at the bottom. This way, they slowly formed these massive blobs of recycled crust. Scientists haven't agreed on whether the blobs are heavier or lighter than the rest of the mantle. One study suggested they are denser, which would mean they're made of heavier material. Another study suggested they are less dense, meaning they could be hot, rising plumes of lighter rock. The African blob is suspected to be one of the causes of the South Atlantic Anomaly, but scientists are still investigating how exactly they are connected. Since the African blob is basically a giant dense blob sitting on top of the outer core, it could cause troubles. The African blob is hotter and possibly chemically different from the surrounding mantle. It could be disturbing the outer core, affecting the magnetic field, weakening it. Another crazy thing is that they might contain an ocean of water locked inside their minerals. Scientists discovered that huge amounts of water, as much as all of Earth's oceans combined, are trapped in minerals deep in the mantle. One mineral, ringwoodite, can store water inside its crystal structure, but it's only possible under extreme pressure and super hot temperatures, like in the deep mantle. So there could be vast hidden water reservoirs inside the blobs. Not literal bodies of water, of course, but tons of little water molecules weirdly locked away deep beneath the surface. If this water were somehow released, it could potentially trigger massive volcanic activity, or even affect global climate. But the blobs are not the only factor for this weird anomaly. Other factors also contribute, like the tilt of Earth's magnetic field, changes in the core's iron flow, and even plate tectonics. However, the large provinces are making things worse. They keep evolving somehow. Scientists think that it might be because massive columns of hot rock called mantle plumes are rising from deep inside the Earth. These plumes could be pushing the giant pieces of Earth's crust like tectonic plates around, especially in the Pacific Ocean. If this is true, then these giant underground blobs aren't just sitting still. They're moving, changing, and shaping the Earth's surface all the time, almost like they're alive. So what does this mean for the future? If the African blob continues evolving, the South Atlantic Anomaly might get larger or shift further, affecting more satellites and spacecraft. Right now, there are still more questions than answers. Every new data point, helps predict how it will evolve and whether we need to worry about the worst-case scenarios. For now, NASA isn't panicking, but they're watching very closely. Because whether it's a harmless shift or a sign of something bigger, one thing is clear: something deep inside Earth is changing. Not a lot of people have heard of this mysterious body of water named after famous English explorer Sir Francis Drake. Even though Drake himself never sailed through these waters, one of his ships did pass near this location and discovered a connection between the Atlantic and Pacific Oceans. That's how the area got named the Drake Passage in 1578. Soon enough, the passage became known for some mysterious disappearances. It got the reputation of being the roughest and most unpredictable stretch of water in the world. It's now known for its strong winds and rough seas, with waves that can reach up to 60 feet in height. The passage also has powerful currents with speeds never seen before. Does it sound like a good start to an adventure book? Sure, it doesn't make the place any less real. If you ever decide to travel between the southern tip of South America and the southern tip of the Antarctic Peninsula, you will come across the infamous Drake Passage. We call this place the Drake Passage today, but locals still believe it should be named after Spanish explorer Francisco de Oces. He was a Spanish navigator who, in 1525, led the first known European expedition to navigate the Drake Passage. The trip was part of an attempt of Spain to find a new route to the Spice Islands in the East Indies. Oces and his two ships, the San Lesmes and the Santiago, sailed through the Strait of Magellan and into the Drake Passage, where they encountered treacherous weather and rough seas. Despite the difficulties, they successfully navigated the passage and became the first Europeans known to have done so. However, the expedition failed to find a new trade route, and the crew returned to Spain with no significant discoveries. Some years later, in 1616, another ship captained by Dutch navigator Willem Schouten made one of the most successful voyages through the Drake Passage. Despite the difficulties of navigating the often turbulent seas, eventually, the Drake Passage became an important part of international trade routes in the 19th and early 20th centuries. But this dangerous area holds many secrets. The record of one of the most famous events that happened here takes us back to the year 1914. During that time, a British explorer named Shackleton wanted to travel to Antarctica with 27 men split between two ships. Those were named the Endurance and the Aurora. The explorers wanted to check out two routes that reached the continent. But in 1915, the Endurance got stuck in ice while crossing the Drake Passage and was slowly crushed. Shackleton and his crew had to leave the ship and could only gather some personal belongings. The Endurance eventually sank, and the crew had to survive on ice for a while. The mission changed from exploring to surviving, and only in 1916 all the men were rescued. The Aurora suffered a similar fate. It also got stuck in ice, and 3 men were lost at sea before the rest of the crew was rescued in 1917. For many years, the ship Endurance was thought to have been lost forever. But in 2022, a group of specialists went on a trip to find it. They left from Cape Town, South Africa on February 5th. The leader of the group said it was most likely the most difficult shipwreck search in history. They used special equipment to find the ship under the water and then used a special underwater camera to take a closer look. The members of the team were sure they had found the Endurance because it was in a place where very few ships had ever been. Despite being 10,000 feet underwater, the Endurance didn't look so shabby. It was actually pretty well preserved for a ship that had been underwater for more than 100 years. The explorers were still even able to see the word Endurance written on it. But it's not just ships that have a hard time with the Drake Passage. A plane with 38 people on board seemed to have disappeared over the Drake Passage in 2019, according to the Chilean authorities. It's believed it hit the icy and rough waters of the passage. Rescuers used ships, planes, and satellites to search for the missing plane and its passengers in the area where it had last sent messages. But the harsh conditions of the Drake Passage made the search very difficult. The exact location where the accident had happened was eventually found, but there were no survivors. The Viking Polaris is another of those ships that got damaged in the passage, even though it was designed for tough conditions. It was faster than most ships and more stable because of special equipment that kept it balanced. One night, back in 2022, the waves were indeed big, but the ship seemed to be doing well in the rough weather. But then, on its way back to port in Ushuaia, Argentina, a rogue wave suddenly hit the ship without warning. People on board felt like they had been hit by an iceberg. Rogue waves are much taller than other waves around them, and they're very unpredictable. Scientists still don't know exactly why they occur. When this rogue wave hit the Viking Polaris ship, it immediately broke windows on the second deck. Some people on board were hurt, but thankfully, most of them had been properly trained before boarding the ship and knew what they had to do in case of an emergency. The crew was also very good at helping the passengers. Most of them even claimed later that they would board the ship for the second time, despite such an unexpected experience. The boat eventually made it to the port without suffering further damage. What makes this region so hard to cross, though? For starters, the Drake Passage is a wide and deep area of water. It's about 500 miles wide and has a depth of 15,000 feet. Even the most experienced sailors who cross the passage every year say it can be dangerous, unpredictable, and even scary at times. And that's even considering the modern technologies we have today. The area is a mix of warm and cold temperatures, which can result in ravishing storms. Strong winds from the west push the water from the Pacific Ocean into the passage, creating waves and swells that can reach up to 30 feet or more. If accidents happen here, things can get ugly faster than anywhere else. The Drake Passage is a part of the ocean where the water is very cold and has strong currents. The bottom of the ocean there is also not stable, making it harder to find things like a plane or a ship. These days, we have modern technology that helps us feel safe, even when we're passing through rough seas. However, if you are planning to travel by boat to Antarctica, make sure you're ready for the rough sea in the Drake Passage, and for feeling a little uneasy. This can happen even to the most experienced of people when the waters are rough. But it's especially tough if it's your first time. Some people bring remedies to avoid feeling sick, like ginger gum or scented wristbands. Others find it helpful to look at the horizon. Test things out to see what works for you. Once you arrive at the Drake Passage, you'll be surprised to see that lots of different animals live there. You can see many types of dolphins, birds, whales, and penguins. The water in the Drake Passage is also good for small animals like plankton, krill, which bigger animals such as whales, penguins, and seals generally have on their daily menus. As you get closer to Antarctica, watch out for the South Shetland Islands. These might be the first pieces of land you'll see. They're also located in the Antarctic Peninsula and were first discovered in 1819 by British explorer William Smith. The South Shetland Islands are home to severe active volcanoes, including Deception Island and Mount Fenton. The islands are also where you can find a number of endemic species, including the South Shetland Islands Gentoo penguin, which is only found on this piece of land. There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring Forties, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land. So they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings, and they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore, but still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. Workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the canal zone and finished it by 1914. It cost the US around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges.
Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean, drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. Then you might survive, but there's no guarantee. At the same time, If an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They looked like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go. See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and watch the volcano's activity, listening for a rumble that may someday come again. In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice, the size of a van, began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the Earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, Did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech, too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more. But getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material, which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon: the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991, even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that ice quakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. Mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started, but not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these three. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
Imagine a world where instead of water, the oceans are made of methane. Yeah, that's right. Instead of swimming in H2O, you'd be paddling around in CH4. It's like Mother Nature's version of a fizzy drink. Such oceans actually exist on one of Saturn's moons called Titan. In fact, the methane and ethane on Titan play a similar role to the water on Earth. They cycle through the atmosphere and form clouds that eventually rain down onto the surface. They were discovered by the Cassini-Huygens space probe, and apparently, our entire planet's oil reserves could fit in one of Titan's puddles. Even the desert sand dunes on Titan have more organics than all of Earth's coal reserves. Who knew that Titan was the place to go if you're ever in need of fuel for your car? Now, obviously, there are some things that distinguish methane lakes from our water ones. First, the temperature on Titan is around negative 290 degrees Fahrenheit. It's like taking a dip in a giant glass of liquid nitrogen. Not exactly ideal for a beach day, is it? Methane is also less dense than water, so if you were to go swimming in such an ocean, you'd float like a balloon. On the bright side, it would make doing the backstroke a lot easier. Next, while water waves can be pretty majestic, unfortunately, we can't ride any on Titan. Cassini didn't detect any big waves there. Maybe it's due to low seasonal winds, or the fact that some of the lakes are much smaller than Earth's lakes, but we don't know for sure. Also, I know what you're thinking. If the oceans are made of methane, could you set them on fire? Technically, yes. Methane is a highly flammable gas, so if you were to light a match in a methane ocean, you'd get a pretty impressive, but dangerous, blaze. So, given all these differences, the question arises, what would a planet with such oceans look like? Well, we can make some guesses by looking at Titan. First of all, its atmosphere, composed primarily of methane, would be incredibly thick. Titan's atmosphere reaches nearly 370 miles into space, and the atmospheric pressure there is 60% greater than Earth's. So, if you ever wanted to experience the feeling of swimming super deep in the ocean, now's your chance. Also, methane is a powerful greenhouse gas that traps the sun's heat really well. That's why our planet would warm up faster than a sauna. You may ask, why is it so cold on Titan then? This is because this moon is very far from the sun, and light doesn't reach it well. But if we place our planet somewhere in the middle, then the temperature may even be quite comfortable. Actually, methane oceans on a planet could really spice up the climate. The planet would be a breeding ground for methane clouds. Just like on Titan, it could form an orange-colored haze, or smog, that would make our planet look like a real mystery. It would be difficult to see us from space without some special telescopes. And let's not forget about methane storms. They would also occasionally drench the surface, so remember to bring your umbrella. But hey, At least the heavy, carbon-rich compounds would make for some pretty sweet dune fields. And finally, the most important difference. While water oceans on Earth are teeming with all sorts of creatures, we're not sure if there's any life in methane oceans on Titan. If there is, they'd have to be pretty tough to survive in such extreme conditions. So, if life on such a planet exists, it would be very different from what we're used to seeing on Earth. For example, microbes might be able to handle it. These tiny resilient creatures can survive in a wide range of environments, including extreme ones. So it's possible that microbial life could exist in methane oceans. And what about us and animals? Well, scientist Robert Zubrin thinks that Titan might be the perfect place for humans to colonize in our solar system. According to him, this little moon has everything we need to survive and thrive. And if it's possible on that moon, then it could work with a planet too. For starters, we'd need some oxygen to breathe. We could use nitrogen and methane in the atmosphere to create breathable air and rocket fuel. We could also use these elements to make some fertilizers and grow plants. Next up, we'd need water. Since the oceans are made of methane, we can't exactly drink them. We'd need to find or create sources of water. Scientists believe that it actually may be hidden below the surface on Titan, together with some ammonia. We could use it to drink, or create even more oxygen. So, with all of these resources, we could create a self-sustaining colony even in a place with methane oceans. Piece of cake! Although, there are always alternatives. Maybe we could become methane breathers, evolve into organisms that use methane instead of oxygen. For example, we could get some large lungs because we'd have to inhale a much larger volume of air, since methane is less dense than oxygen. But this is pure sci-fi. Methane oceans are not the only unusual oceans in space. It turns out that seas on diamond planets may be even weirder. Take WASP 12b, for example. This exoplanet, located about 1,200 light-years away, might have oceans of tar. That's right, tar. The planet has more carbon than oxygen, which means its crust is probably made of things like diamond and graphite, instead of your average silica-based minerals like granite. Imagine stepping on this planet, and the first thing you notice is that the beaches are made up of black goo. It's like stepping into a nightmare, where you're trapped in quicksand made of sticky sludge. So forget about the sandy beaches and crystal clear water you're used to. Here, you'll be living the pitch life. Your swimwear will be replaced with hazmat suits, and you'll need a sturdy pair of boots to walk on the sticky surface. But in reality, WASP 12b is not the place to look for geology of any kind. It's simply too hot for anything to survive, let alone thrive. But there might be smaller, similar exoplanets where we could potentially live. Now, you might be thinking, tar oceans? That's crazy talk. But did you know that there's a 246-foot deep lake of natural asphalt here on Earth? It's called Pitch Lake, and it's located in Trinidad. It's formed when oil is forced to the surface, and the lighter components evaporate, leaving the thicker, heavier pitch behind. And guess what? This lake is home to a thriving ecosystem of microbes. So if you want to live on such a planet, at least you won't be alone. You'll have plenty of company in bacteria, fungi that love to feast on carbon found in asphalt, and archaea that live on methane. And finally, there are oceans of molten rock. That's right. Imagine a world where the floor is lava isn't just a game, but a reality. Welcome to 55 Cancri E, a planet so hot that the entire hemisphere facing its star is covered in magma. It's like a scene out of a heavy metal album cover. But don't worry, the other side of the planet is slightly cooler, so you can at least step off the lava and catch your breath. If you're feeling adventurous, you could always hop over to Koro T7b, another super-Earth where the lava ocean is just as scorching. But this time, the night side doesn't offer much respite either. It's still seeing constant volcanic eruptions, like some sort of fireworks show. Scientists are scratching their heads trying to explain why these planets are so hot, and why they haven't cooled down yet. Maybe they're just really good at retaining heat, or maybe they just have a bad temperament. Either way, it's probably best to stick to playing The Floor is Lava on solid ground, and leave the real lava planets to someone else. All this diversity of oceans shows us that the universe is always full of surprises. It never ceases to amaze us with its creativity. Although these oceans are not suitable for human exploration yet, they challenge our understanding of what could exist beyond our world. So, let's continue to explore.
In 1945, 5 TBF Avenger aircraft took flight for a routine training exercise around the Bermuda Triangle. In the middle of the exercise, the planes were struck by intense rain and heavy winds, despite the clear weather forecast. The pilots became extremely disoriented and radioed the base to report that their navigational equipment had stopped working. The last thing the base heard was, "When the first plane drops below 10 gallons, we'll all go down together," and then static. The 5 planes and their 14 crew members were never seen or heard from again. On his very first voyage to the New World in 1492, Christopher Columbus sailed through the Bermuda Triangle. Columbus reported that one night when he was on the deck of the ship, he noticed a giant light appear in the distance, unlike anything he had ever seen before. Columbus looked at his compass for direction, and it gave off erratic readings. You might have noticed that the Bermuda Triangle doesn't appear on any world map. This is because official institutions refuse to acknowledge that the area actually exists. A popular theory suggests that rogue waves are responsible for the many disappearances. Rogue waves are called extreme storm waves by scientists. They occur when different weather patterns take place at the same time and cause large, unexpected waves. Witnesses say that the waves look like giant walls of water. These waves could explain why ships go down fast and without leaving any trace. The Bermuda Triangle is home to some pretty intense and unexpected weather. Storms build up quickly and unexpectedly, then disappear soon after. If you blink, you might miss it. This could explain why few distress signals are issued. Pilots and sailors never saw the weather coming. No one knows exactly how many ships and planes have disappeared in the Bermuda Triangle. The rough estimate is 50 ships and 20 planes. Most of the time, the disappearances had no explanation and no wreckage has ever been left behind. Another bizarre theory trying to solve the Bermuda Triangle mystery comes from Charlie Berlitz. He insists that the area is home to the lost city of Atlantis. The missing ships and planes and malfunctioning equipment, according to him, were all caused by rays of energy let out by the special energy crystals that power Atlantis. While this sounds silly, Berlitz's theory was convincing enough that over 20 million people bought his book worldwide. In the year 1800, a large sailing vessel called the USS Pickering departed from the U.S. on its way to the West Indies. The ship sailed into the Bermuda Triangle along with its 90-man crew and was never heard from again. The USS Pickering was the first ever confirmed ship to vanish in the Bermuda Triangle. It's believed that the ship was taken out by a storm, but because no wreckage was ever found, we'll never know for sure. When the TBF Avenger planes went missing, a massive search operation was conducted. Boats and planes searched the Bermuda Triangle for any signs of the aircraft. One of the boats searching was a PBM-5 Mariner airboat. The airboat took flight at 7:27 p.m. and called in a routine radio message 3 minutes later. Then, it was never heard from again. No trace was ever found of the rescue airboat or the 5 Avenger aircraft. An enormous investigation was launched into the disappearance of all these vehicles, but nothing was ever discovered. This particular area of the ocean is one of the most heavily traveled shipping routes in the world. Some skeptics believe that this fact solves the mystery. Statistically, the busier the area, the higher the frequency of accidents and disappearances. While this makes sense, it's not the frequency of disappearances that's responsible for the mystery of the Bermuda Triangle. It's the lack of explanation or wreckage found. On the ocean floor, decomposing organisms let off large concentrations of methane gas that gets trapped under the water. This gas can build up until, boom, it ruptures. The gas surges up to the surface and erupts. If a ship was in the area of one of these ruptures, the water would become much less dense and cause the ship to sink rapidly and without warning. Scientists believe this could be the cause of the many disappearances in the Bermuda Triangle. While this theory makes a lot of sense, it doesn't seem too likely. The U.S. Geological Survey has stated that no large releases of gas are believed to have occurred in this area for the past 15,000 years. The ocean floor is made of rocks containing a lot of magnetite. It's more like iron. Magnetic fields react to high concentrations of magnetite on the ocean floor, which may start a sort of conflict between the two. It can often lead to various weather anomalies and, as a result, navigation issues. And, naturally, any changes in the ocean floor or the Earth's magnetic fields influence the Bermuda Triangle a lot. Since the magnetic field is constantly moving, it might be also taking the Bermuda Triangle with it. Now that people know where the triangle is, it's easy to avoid it. It supposedly moves eastward together with the magnetic poles. But scientists still can't answer where exactly it will be in a couple of years. Some people blame all the disasters on the extraterrestrial paranormal activity. Others suppose it's all about raging natural phenomena. There's another triangle in Lake Michigan. Just like the one near Bermuda, the Michigan Triangle got its shady reputation for some disappearances. The first recorded one dates back to 1679. A large vessel, one of the largest of that time, set out on an expedition. Yet once it got in the sinister triangle, it never came back. Much later, an aircraft disappeared in this triangle. The skies are usually very clear there, but back in 1883, some people witnessed abnormal things in the area. Some claim to have seen large blocks of ice falling from the skies, and the crew even managed to save one as hard proof. Meanwhile, the Pacific Ocean Mystery Area is another sinister triangle. Off the south coast of Japan, not far away from Tokyo, there's a sea where plenty of ships met their doom, disappearing without a trace in these waters. They call it the Devil's Triangle. Some scientists believe the cause of anomalies is the environmental changes. Also, there's a really high concentration of methane hydrates on the bottom of the ocean in the Pacific Triangle area. You're deviating from your original course and sailing in the wrong direction. There's the Caribbean Sea near the triangle, peppered with small islands. The seafloor here isn't deep. The ship can get in shallow waters. And now the ship is stuck on a shoal, and you have no idea where you are. If this were the 21st century, the ship's captain would be able to reach the shore using GPS and other modern navigation. But the most interesting thing is that the compass would work correctly this time, since the magnetic North Pole hasn't already coincided with the true one for a long time in the territory of the Bermuda Triangle. The agonic line is somewhere far away from here. There are no problems with navigation now, but for some reason, this is where ships disappear. In fact, not just here. Throughout the Atlantic Ocean, there are places where many more ships were gone. The Bermuda Triangle is not even in the top 10 of such places. One of the main reasons why many ships are lost here is that one of the most popular shipping routes in the Atlantic passes through the Bermuda Triangle. And the more ships in one place, the more shipwrecks. Simple probability. Then, it just starts getting weird. Other theories say that there's a space-time rift in this region. Ships and planes fall into this rift and end up in the past or the future. But for some reason, there's not a single proof of this myth. There's no reason to think that the rift is hidden somewhere here. The base of an extraterrestrial civilization is located in the Bermuda Triangle. Visitors from other galaxies steal sea vessels along with the crew, so no one finds the wreckage of the ships. This is also a popular myth that has no scientific justification. The Kraken lives somewhere in the triangle. It's a huge squid that sinks ships and also is a legend that sailors tell each other. However, gigantic squids live in the depths of the ocean. They can grow to the size of half a train car, but no cases have ever been recorded where they sunk a large vessel. And in the area of the Bermuda Triangle, they have never ever been seen. People in the past didn't know about the existence of these creatures, so when they saw them for the first time, they described them as huge, terrible monsters. Giant squids are some of the most elusive creatures on Earth, and scientists had to use sonar equipment to find them. They don't like to leave the dark depths and are likely to be afraid of the sound of any ship. So, that should squash the squid as a suspect. Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all that is salt water from the world's oceans. There aren't any borders between the four oceans we've all come to know. But oceanographers and the world's countries did traditionally split these waters into four distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the fifth body of water. It's called the Southern Ocean, and three of the four original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land, and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space of the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation.